I'm here with Z from RIC here in Los Angeles, California. Thanks for having me at your headquarters today.
No problem. See a lot of your videos, love your videos. Glad to be on the show.
Thank you, man. I did a video with your company earlier and featuring some of the great footage that you had of your projects over in China. Now you have this office set up in Los Angeles. Your printer's pretty unique. You've got an attachment on the extruder head to extend the range from a typical robotic arm, and I even saw it on a track system. It's a cool technology. I guess let's start off with how did this company begin and where did it start from for you?
Okay, great. So the company started off as a research project back in China, and then after that we did a series of projects that we can show you videos on later on. But I came here for grad school, and in my studying career I figured out the technology can have so much use here in the United States, and especially with the cost and with the way we do things, it will have a so much better market here in the US. So that's why we decided to test it out. We shipped our first printer here last December, and then based on the printer, we developed a whole material system that uses all US local materials. So that's to save costs, and then to shipping, and then to have a more consistent material supply.
Yeah, I mean, you say last September, which is super recent, but there was a lot of research and development in China to help you build on.
Yes. Before that, we had about 140,000 hours of research hours combined together. So that's why we were able to gain a lot of knowledge, and that's why we know what criteria, what performance we're looking for in our printers and our materials. That's why we were able to get something that's unique and then something that's workable with such a short period of time.
In the videos, everybody pays all of the attention to the printer, but you were mentioning a big part of the R&D struggle is actually the material.
Yeah, because the material is more important than the equipment in a sense, because anybody can technically put together a 3D printing system. It's not rocket science. A 3D-dimensional locating system, you can do it with a Gantry System, you can do it with a Robotic Arm. That's something that's already available in the construction industry and then in the manufacturing industry as well. So you just bring those in and then you attach it to a semi-smart concrete pump. And then, but from that point on, the printer and then the mixer pump together creates a unique dynamic and a unique criteria for the material to work. And that's actually where the science and where the majority of the R&D goes in. Because you want the materials to be sticky enough, but also flowable enough to be extruded, and then you want it to set in a certain amount of time, but not too fast so that it clogs the system. And also you want to be able to do cantilevers, you want it to do different shapes, and then so those are just different criteria to want to go.
So this material you actually have in here, is that spare, you're so busy you don't have extra room for stuff, or is it for demonstration purposes?
That's actually because we want to consider us as a very cost-efficient company, and that's why we use every bit of space, including the office itself, as storage. That's, I mean, the lower overhead we have now is the overall lower cost, and then that's how we are able to bring our material and our equipment, our software to the market with such a competitive price.
Yeah, cool. I mean, it's great just to see in terms of this is how it started, and then you see all the printed objects around. This is what it became.
Yes, definitely, because it's definitely a struggle for the last 6 months, especially after the printer arrives. We've seen a lot of collapses. It's not even funny. Our trash company hates us.
Every 3D printed construction company or anyone who's operated a printer knows what you're talking about. It's never easy.
Yeah, but actually, the way our company works, we are a technology company. So we see a problem, we deal with it, we solve it, including the water system, because the fire department hates us in the beginning. So now we come up with a system where we basically recycle all our water in-house, and it comes out clean and dry. The only stuff that comes out is in the bag, and then we throw them out with all our other construction trash from a construction
disposal site.
Disposal, yeah. So everything is in order, and then it's not damaging the environment.
So you make a bunch of concrete mixes and you print a bunch of stuff and you see what doesn't crack?
Well, because from our previous experience, we know how to make it not crack. So I think our stuff only cracked once. That's in the very beginning, And then now, like even with like very long, very skinny prints, we have now seen cracks. And then the compression test, I mean, right now, our most current and most cheapest mix, it's reaching about 7,500 psi in 2 weeks, and that's and that's way more than enough to do 3D printing housing.
Yeah, it's always a struggle printing in a new location, dealing with some unforeseen circumstances if you have to get new materials or even some of the changes like temperature, humidity. Do you have any plan for addressing that when you start printing in many different regions?
Yeah, so that's why when we started off this material research here in the US, we are adamant on using local materials. So first of all, cement, we use the most common Portland cement that you can find in the country. You can literally go to Home Depot and buy the same cement. And then the sand, we use it from one of the largest sand quarries from the States, the Vulcan company. They have great sand for really reasonable price. And then so those two are actually the majority of the costs. And then the way we bring that down enable us to have like a lot of room for additives and such. And then also all the additives we purchase from local distributors. And then so they first of all to support US businesses, and then also to have a really strong supply of the material itself.
Is it C52.5 or I52.5, something like that?
You mean the additive or
the cement mix?
Oh, the cement itself is just type 2.5. It's the most common ones in Home Depot. Yeah, so I mean there's very cement. Make no mistake, but we want the most common because that's what will enable us a most sustainable supply chain.
Yeah, definitely, and scalability. I mean, if it's available at every Home Depot, you don't have to worry about shipping things in long distance as much.
Exactly. And then, even though 3D printing as unique as high tech it sounds, the majority of the cost at the end of the day, it's still the material itself. It's still the conventional, getting the stuff to the site. And then even though 3D printing eliminates a lot of the moving parts, but those still factors in the overall cost and delivery for the customers.
On top of that, at the end, the printer goes away, the material's there forever. So
exactly.
So like you're saying, the most important. You've taken a very holistic approach to 3D printed buildings on some of your projects in China, even printing part of the roof.
Exactly. So the research done in China, led by a professor that was a purist, and he is adamant on every single piece from the foundation up that is 3D printed concrete. And then one of the results we have is a arched roof that has been able to give us a very strong roof and with a unique design. Not everybody loves it, but that is certainly a purist way, and then one of the only ways currently to 3D print every part of the building.
Yeah, it's very uncommon to see a printed roof. I don't know if I've even seen another one besides the guy in Italy who printed that kind of just
the dome. Yeah,
it looked like a cardboard house almost. So you're an architect by education, or you were going to be an architect?
So I was trained as an architect as undergrad. I went to school here, first graduate school for architecture, and then I decided to go to Ivy League because why not? And then, but when I actually went there, I realized there's so much more I can achieve with my life, and there's so much more I can, build with the current resources I have. So I did what every so-called startup founder did. So I dropped out and started a company back here in Los Angeles.
So coming from that framework of design, is that the most interesting part of 3D printing for you, or?
Well, I'm a 3-generation architect family, and then so even my grandfather before my father was an architect.
Wow.
So we've been seeing a lot of challenges as architects, especially the communication between architects and the GC. I mean, the developers want something that's in their mind, but it's architects to realize that plan, and then but it's general contractor, and then their subcontractor, and then their labor to actually realize it. And then that's a huge information loss through every step.
Yeah.
And then it will always come down to, as you were saying before, architect design something, and then the GC that guy does not know what he's doing, even though he might be architect for 30 years. And that's a problem in the industry because it's still a craftsman industry, and then it's really down to the last man who does the job that gets it done. Even though he might have tools, but it's not standardized, it's not as considered as a machine. So the architect doesn't really know. He might have some idea of what the guy can do, but he doesn't really know. So right now, that's why we decided as architects to do something about it using technology, and then using machines, and then softwares, and AI, and then all the good stuff. That the result is something the architects can understand, because all architects play with tabletop 3D printers, and then in that way, it's something that is reachable, and then it's something that's simulatable on their computer.
Something that actually follows your directions.
Exactly. If you want to go a straight line, you go a straight line. If you want a curve, that's a curve. It's not, I want a curve, and then the GC says, I maybe can do it, and then their subcontractor, I'm going to charge you 3 times as much, and then their guy said, I'm not going to do it. So that's about months later, and then it costs the developer a fortune. The architects say, my design is not realized, and then everybody might not end up hating the end result. But by introducing technology, introducing robotic arms, introducing AI technology, you can have something that the architect designed, and then he know exactly how it's going to come out. That's something that we as architects really wants to have, and then that's something we have been trying to give to architects. And then actually, at the end of the day, all of that cost saving ends up being a lot better product with a lot cheaper overall price for the customer.
Is there a big difference between this mix and the mix for those?
Oh yeah, so this is actually 3 different mixes.
Mm-hmm.
So that mix was about almost half a year ago.
Very dry.
Yeah, that's very dry, and then it cracked a lot. That's when we were first able to print something.
Yeah, but it's a different kind of cracking. It's not a through and through vertical crack.
Yeah, so that crack we call it loose.
Mm-hmm.
Because the binding agent is not doing its job correctly.
Yeah.
And then, so these 2 mixes are our high pressure, and then to do cantilever, you can see that just going in and out, has no problem doing cantilevers even at 45 degrees. And then that's also a material that doesn't cost a fortune,
mm-hmm.
because there are material on the market that costs about $1,200 per superset. Per ton, basically $1,200 per ton. It costs about 30% of that.
Wow.
And then that's a different mix. That's our building mix. That's a little less strength.
Yeah, it doesn't need the overhang ability.
It doesn't need the overhang. Yeah, so that costs about 75% of the other mix. But that's, first of all, the strength is enough, it doesn't crack, and then as long as it's going straight upward, it has no problem with it. Yeah, so we really take different scale and different type of product we're printing into our mix designs to give the best solution for that product.
Do all your mixes get mixed completely before the hose, or do you have any accelerants or retarders at the extruder head?
So that's something you can see when we're printing. So everything gets mixed before it's in the big mixer.
Mm-hmm.
So we use a batch mixing.
Mm-hmm.
That's a little easier to control, and it allows you to do faster pace.
Mm-hmm.
And then that's the new machine. That's our first prototype that you're going to be able to see.
Cool. So the mixing pump system is obviously a very important component.
Yeah. So and in the beginning we were using a separate mixer and a separate pump, and that's actually a lot of labor involved. And it's very dangerous. Our guys need to lifting 100-pound boxes, and that's just
not ideal.
Not ideal, exactly. And then that's why we came up with a system where the material lifts itself, dumps itself, mixes itself, and then after mix, it dumps into the pump automatically, and then it just pumps out. So now it's a 2-man job instead of a 3-guy job.
And we'll see that today.
Yes.
Very cool.
Yeah. And then so we developed all the system itself, which the only thing that's purchased is the robot arm, but that's also early on decision we made. Using a gantry system, ideally is great. You set it up and then it's moving and then you cover the whole space. But there's drawbacks to it because first of all, you need certain amount of space to start printing, and then the gantry system itself, it costs a fortune, and that's why a lot of 3D printing companies have great technology and it's not really scaling, and then so that's why we took the approach of how do we get is very consistent and very mass-produced product to do this three-dimensional locating system. And then one of the most massively used technology is robotic arm, the 6-axis robotic arm. And then that thing costs a lot in the States as well. But the company we use, KUKA, was bought by a Chinese company. They manufacture that in China now, and it's just half the price.
When was KUKA bought by a Chinese company?
Don't quote me on that. It's about 3 years.
Interesting.
3 or 4 years ago.
Cool.
And then they have their own plant in China, and we are one of the few companies that's allowed to export the whole system.
Nice.
I mean, because we don't export the robot arm, we export the 3D printing concrete system, and then that's how we are able to get like a insane cost compared to everybody else.
Do you have your printer for sale?
Yes, we do. So our printers are in 3 different shapes. The standalone, the stationary one, which is good for printing about like small ADUs, and then small affordable housings are
Sculptures
or even smaller to sculptures, and then landscape products. It's about 160K. That's with the pump and mix unibody.
Wow, that's affordable.
Yeah, that's one of the most. That's one of the most important parts that we want to do. That's something that's really affordable, and then we have the capability to pump our machine about 20 units a month, and then the lead time is about 3 months, and then that's to play it safe because of the pandemic and then the shipping, all of that taken into consideration. So the reason we were able to get that is that every single piece is modular, and then nothing is like a huge thing that has a huge lead time. And so we take every part down to the smallest part, and then it's the most easiest way to construct.
That's the shortest lead time I've heard of for a concrete printer. They're all 4 months, not 3 months.
Yeah, well, and then the way we can, it's not that we, and then the way we do it is not, we can build this for 3 months, and then the next one 6 months. It's like it doesn't matter if we want 10 or we want 1. It's all 3 months. Mm-hmm. Because we have a huge factory back in China, and then it's loaded with parts, and all we need is to assemble them together. And then those 3 months largely come from waiting for customs and waiting for shipping and such.
How long does it take to train a new team on your system?
So, to train a team, it's a 2 different training part. So one part is actually operating the system itself. Mm-hmm. That takes about a week, because to be able to use it takes about 30 minutes to explain how to use it. But to know the ins and out, where to clean, and how to actually know the concrete flowing correctly, that takes about a week.
Yeah.
And then, but the other guy, which is basically loading the material and then cleaning the machine, that's about 30-minute training. Mm-hmm. So the 2-man team can be assembled anywhere with one of our technicians in under a week.
Nice. Yeah, the Gantry system, the only obvious advantage I've seen compared to a robotic arm is building a monolithic structure, where it's all one continuous layer throughout, like, say, a 2,000 square foot building.
Yeah.
But here in California, you're not allowed to do monolithic concrete anyway because of the earthquakes. You can only have up to like 6 or 8 feet.
Yeah.
So it doesn't seem like there's really any advantage to the Gantry system here.
Yeah, I mean, the debate between Gantry and then robotic arm is going to be ongoing forever. But the way we see it is that the robotic arm is at a human scale, and then that does not disrupt any of the current construction industry at all. So I hate when people say, we're going to disrupt this industry. That's not going to happen. You are a startup. You're not going to convert a 1.6 trillion industry overnight. So what we can do is, I'm quoting Caterpillar here, is incremental value add to the industry. So you see the problems of the industry, you help it with technology bit by bit, and then you're supplying with the industry with more productivity, not converting it, not losing people jobs.
Yeah.
What we're doing here is that we are giving people more people the opportunity to work on construction. Because before, you have to be fit and be strong, you have to take certain risks, and then you are more likely to be injured in the industry because you're moving material. And also on top of that, you have to be skilled. And all of that takes a lot of people out of this industry. And then, but what we do is that we make the system so easy to use. And you can see it's literally just push buttons and then cleaning the thing. more people can come into the industry. To operate the machine, you can now have disabled people. You can now have veterans. You can have people from different genders come into the industry. Now you don't have to lift 100 pounds. All you have to do is, the most you're going to lift is a panel or a water jet. That's all you need to do.
Yeah, with the batch plant mixer, it's nice. I was doing some mixing, lifting the 25 kilogram sacks. It gets tiring.
Yeah. So now the only lifting is lifting the box with the material into the material box that's literally almost on the ground.
Sure.
So it's like half a feet of lifting, and that's it. And then you can break that down into small batches. It'd be much easier.
Yeah, and so we'll see this later, but when you're mixing your material at the batch plant, you load in sand separately from the cement, separately from the water.
No, so sand and cement and all the additives
Get mixed first.
No, it goes into the box.
And separately or together?
Together. And then the water, the system has a water jet, and it's very accurate, but we're not using that today because our hose kind of broke and then it's leaking everywhere. So now we're just dumping in the water, and then when we hook up the hose, when the machine will be working 100%, only thing you have to do is load in the sand, cement, and additives to the material box, and that's it. And then the water injection is accurate to about 1 millimeter, and then you can tell how much water you need, and everything else is automatic.
So you have to just be careful when you're mixing it, getting precise ratios.
Yes, I mean the precise ratio of the sand and cement. Yeah.
How much leeway do you have? Like if you accidentally shovel in an extra shovel of sand, is the whole thing ruined, or?
Well, not really. It's actually the water that wins and kills the material, and then that's why we have a very precise water jet, and then that's actually wins and kills it.
Printing outside, are you conscientious of the temperature changes, and do you make adjustments to the mix through the day?
Yeah, so with this, while we're developing this, in California you have huge temperature changes, about like the minimum is about 20 degrees during the day. So in the beginning it was a big problematic for us. That's why we developed it inside, so we close the doors to the outside, and then we blast the AC or blast the heater to have a consistent temperature. But 1 week after that, after we got a consistent design, we started playing with the different additives to get it through different temperatures and then different waters and then different ways of doing it. So now we can do it basically from 60 degrees to almost 100 degrees. And then the way to change it is just adding our add-in mix or simply add more water. It really depends on the temperature of the day.
Have you sold any printers yet in the short time you've been in the States?
Not as yet, because recently we have been perfecting the material and then the machine, and then we've been waiting for the new unibody to come in, because that just saves a lot on labor, and then it just automatically automates the process a lot more.
Yeah, what do you anticipate the kind of popular markets for you being in the States?
Well, majority it will be for smaller to single-story residential housings, and then because the way the machine is, it can do very interesting shapes. So actually, one of the bigger markets is going to be on short-term rental markets. Yeah, so because these just came out, it's very interesting and unique design buildings.
Yeah, like Airbnbs.
Yeah, like Airbnbs. Yeah.
Cool. You plan on doing your own building soon?
Yeah, so we are planning on doing a small demo project for homeless housing, because that's a big issue in California and throughout the States as well. And then we want to use this technology to build semi-permanent housing that looks dignified and has a great exterior and great living conditions. So instead of just putting up a kind of crumbling tiny house, because it doesn't really make sense if you build something that kind of solves the problem but not long term. You want something that looks good and also very cost efficient.
Yeah, in a space like you're in, it's very incremental. Like you're not just coming in and replacing the whole construction process at once. It's beginning with the concrete, the walls. How do you see the evolution of automation starting from kind of like step by step and then far into the future?
Well, from what I see and what I understand, a construction industry, you're never going to really replace the human power. I mean, the human mind is some of the most smart, some of the most sophisticated living organisms in the whole universe.
And all the opposite of that too.
Yeah, and also that brings its problem. So what's the best about this is that you don't let human do the mundane, the repetitive, repetitive, dangerous stuff that's in the construction industry right now. You let the human do the observer, you let the human do the controller, and then do the creative stuff, and then also use the human to solve and deal with problems that come up, and then that's what I think what we're doing here. We're using robotic, we're using automation to increase productivity, and then like you use robot to do the heavy lifting, to print the heavy stuff, to deal with dangerous environment, and then the human can be a governor to the machine. The human can just be there to supply the machine, like, and then to solve the problem when it arrives. Because no matter how automated, how smart, how sophisticated the machine is, it always breaks.
Yeah.
But human minds are smart. Human minds can solve the problem, and that's where I can see them being like a very integrated, almost a cyborg in a whole kind of situation. And then, so that's how our machine and how our development come to be. So we take apart the whole process, and then we take the repetitive, take the dangerous part off, and then the human is still there. It just one person can do so much more in the same amount of time.
Yeah. And
then that's basically the ideology.
What would be some future things you would look to automate besides the concrete wall sections?
Well, because actually, interestingly enough, before 3D printing, before our first printed project, our first project was it was an automated bricklaying system. That's way before all the SAM and then all that stuff. Like we automatically built a curved brick garden.
What size brick?
It was a standard size brick. It was not the CFU. It's I don't know.
2 inch by 6 inch, something.
Yeah, like that. Yeah, it's about like 10,000 pieces, and it was done in like a couple of days.
Cool.
Yeah, and then so we developed the suction cup and then the cement extruder. So it's the 2-in-1 effector head that actually does the whole job.
Yeah, and you mentioned as you were exploring different construction technologies, there were like 12 different options you thought you could pursue, and you decided to start with 3D printing concrete, but you may go into some others.
Well, so that's actually a very early on conversation, about 5 years ago. That's not only 3D printing and robotic arm. It was including, there were 12 different paths. There was AI design, AI something, AI floor plan design, and then there was smart welding, and then there was like a lot of different ideologies we were playing with, because we as architects, there's so much problems.
Yeah.
So we just find 12.
No shortage of problems.
Yeah, exactly. And then the reason we settled on 3D printing concrete is that it contains and it takes up the largest percentage of the building itself. It's basically, when you have the walls, you're almost done volume-wise.
Yeah.
I mean, obviously, like scope of work-wise, you have like so much more to go. But this is like a founding point. So when you get the wall, everything else goes on the wall. And that's why we started on 3D printing concrete, which is the largest percentage volume-wise in the building sector. And then after that's done, since we're using robotic arm, and that's what the more of a reason why we use robotic arm, is that the 3D locating system is there. It's all it does to be, you replace the end effector, you replace it with the grabber, you can put windows, you can put wood, and then you replace it with welding system. The welding system is already there. It's been used in factories throughout the world. You take that, you put a saw on it. It's a very precise cutter that saves the
human
labor, and then it also protects the labor from cutting themselves. And then you take that, you do countertops, which actually costs a fortune to do. From what I understand, one countertop can cost $2 to $6 grand, from what I understand. the robot can do it, no problem. There's no dust that goes into human lungs that cause problem later on. It's just so much easier that the robot can do. So that's why we start with 3D printing concrete, and then but later on the majority of system is already there. It's just about developing the any factors that's already exists.
Yeah, I think the biggest value you're creating is a team that understands how to integrate robotics with construction projects. So as the future evolves, new technologies will emerge, and it'll be teams like yours that understand how to take an STL file from a computer and send that to a robotic arm that'll understand how to implement the technology that exists today, but also the technology that comes tomorrow. Like the guys swinging a hammer aren't going to be able to adapt as quickly.
Exactly. So all of that is to make the whole process easy, make the whole process safer, and then it's taking the skill part of the skill labor shortage that's currently exists, and then from when that happens, like young people who, from what we've seen, from what we understand, hates going to construction industry right now because it's not dignified, it's dirty, it's dangerous.
It's difficult.
It's difficult as well, and it takes a long time to learn, and you might not really understand how to do it in the end. It's taking that part out, but bringing more opportunities, more productivities to the industry.
I don't think the dignified part's the problem. Like people love OnlyFans and all that stuff these days. I think it's that people don't want to sweat and like actually work hard in the sun.
Yeah,
and,
in the sun, in the dust, and like having equipment around you that might swing on you, might injure you, all that part. Yeah.
So what does RIC need right now to grow the fastest?
So I think now we just have what we call capability to build fully scaled housings. So right now we want to develop the current projects we have, and then to have them as demonstration and showcase. Yeah, and then we have about 5 different projects that's in the permitting phase in Arizona, Florida, and in New York.
Nice.
Yeah, so that's actually the hardest part. Like the technology is there, we build stuff, and then that's not a problem.
You picked states that already have at least one permitted 3D printed building. So
exactly, and then what we want to showcase is that not only it can be 3D printed, it can be beautiful, but also it can be really cost effective, using the modular system, using our ideology, using our really reasonably priced material.
So are you starting from the permitting process?
So that's actually a very unique part of our company. So we have a architect firm for 30 years now.
Yeah.
So right now, all our clients that come to us, we actually give them a new understanding of it, and then we do the concept design for them to really fully express how 3D printing can be done. Like, that's something that none of the other companies can do, because like we are architects from the beginning, and then since we developed this, we know every bit of capability that 3D printer can do, and then what kind of spatial experience you can get from the technology. And then that's how we were able to get very interesting renderings. And then these are not renderings, as you can see from our videos. Our renderings looks worse than our real projects, or our projects looks so much better than the renderings, and that's really unheard of in the conventional construction before.
Yeah, renderings aren't good at capturing the way light bounces off of objects, and when you have such a cool shape, like a parametric design, the renderings don't capture the light as well.
Exactly. So that's actually like when we give the rendering to our clients, and wait until you see this when it's built. It's just such a unique and then such a futuristic looking project.
So
came to be.
Coming from an architectural firm that's 30 years old in China, what does Feng Shui mean to you?
Well, Feng Shui is, depending on how you look at it, it can be superstitious, but also it can be what we will call
wisdom
and experience. It's like an old Chinese way of looking at things. It's kind of mysterious, but also it's logic. It's a yin and yang between the both. So you have to look at it subjectively, and you have to believe it and not believe it at the same time.
Yeah, I like Feng Shui, and when it's convenient, I try to follow it, like having a headboard and not having windows behind your bed.
Yeah, or having a mirror in front of you while you're sleeping.
Yeah, I don't even put a mirror in my bedroom. Anyway,
Yeah, that.
So Feng Shui on a scale of 1 to 10, how important would you say it is to you?
I would say it's 5.
5.
Yeah.
I would say to me it's like 6.
Yeah.
Like if I can, I will follow it. But I wouldn't not live somewhere because of.
Yeah, yeah. But if it's something that you really cannot decide on and that you know it's up to fate, that's sometimes you actually want to listen to it.
Mm-hmm. Interesting, and that's following Feng Shui. It's like even if it's against this, sometimes if that's the natural way. Interesting. Is there any other kind of like Chinese design philosophies that you bring from to this company?
Well, here's the thing. I'm trained and I grew up in a Western mindset.
Yeah.
So the Chinese part, I would say, is we want to work really hard, and we want to get the most result out of our work, and then that's just how we are raised. And apart from that, I believe in productivity. I believe in cost efficiency. I believe in giving people rights of what they deserve. Yeah, so those are the things that I really believe in, and then that's something our company follows. And then you can see later on through the printing process, like helping the labor force build better. It's very important, and then it's a manifesto in our machinery and the equipment itself.
So as this company grows and expands, what's your plan for the next 10 years, or looking far into the future?
Well, we would like to use the end of the profit, end of the product as a stepping stone for more technology that comes to the industry. So basically using products and then using profits, putting back in the company, using that resources to develop more unique and a more helpful technology to help the industry in a bigger scale.
Yeah, I like to hear that because it's all about innovation, and innovation isn't ever done.
Yeah, I mean, like it's the construction is just so far behind, and there's so much more. It just off the top of my mind, there are like 100 things that we would like to do, and we have like plans about 10 different types of robots that's developing. And actually, we recently put one of them into plan, which is replacing the track with a AGV platform, and then so that would enable the whole system to move more freely in the construction site, and then putting more of the intelligent part into the system. That's also taking a lot less strain off the supervisor's mind, and that would just give the system a lot more productivity overall.
Why is construction in China so fast? They build like 1 floor per day in Shenzhen.
Well, that's an interesting question. I would say it's several reasons. One of them is labor is a lot cheaper. Obviously, we have so much more
People.
Yeah, that's essentially, and then so we can put more people on single job sites, and then labor cost is a lot less. So that's also how you're able to put more people on the job
You
site.
can work 24 hours.
Yeah, and then the systematic approach is more important because a lot of the buildings are not single story. It's high rise, it's high density, and then you are doing the same stuff over and over, and then that's actually just systematically it's faster. And then obviously innovation is another huge factor. The tallest building in Beijing right now, for that building they build a system that climbs itself on top. So like you build a core and then it climbs up. You build a core, it climbs up.
Yeah, it's really cool.
So innovation and then technology also plays a big part. So to basically, and then I guess the end results for developers is to have the most amount of productivity for their cost, and then that's also a driving factor of how technology are developed.
What about from a company structure standpoint? Like the American general contractors, I like to say it's almost like every single person on the construction site is their own independent entrepreneur. You have the GC and then they hire 15 different subcontractors, then each of those subcontractors are hiring maybe independent contractors on 1099s that say they're the self-employed contractors with their own name on their truck and everything. So you have 100 people working on the job in 100 different businesses with 100 different CEOs, and they're all trying to follow the architect's directions. And it's a mess in America, at least. So in China, is it different?
Well, yes and no. The structure is largely the same. You have big general contractors that takes the whole job, and then that company always, at least in China, fronts the financial part, and that's one of the reasons they can actually get the job. And then they contract that down to smaller GCs that also fronts part of the financials, and then it just passes down. And then yes, it's same and not the same, but the organization, when you're actually building, they control everybody in a more of a military style. So everybody lives together on the site, and then everybody follows like a consistent order in the construction site, and then the one of the reasons the way it's faster is that everybody listens better. Yeah, I think that's one of the.
Yeah, I was gonna ask about that. Like your education. How old were you when you came to the United States?
Well, I actually came here for middle school in the beginning.
Wow.
Yeah, so I understand both sides of the sea.
And then you went back to China for high school, or?
For high school and undergrad. Yeah.
And then here for grad school.
Yeah.
And dropped out.
Yeah.
Cool.
Well, I mean, like me as a Chinese, foreign exchange student in the beginning, it's very important to learn both sides of the culture. You get the best of both worlds.
Yeah, I think America doesn't put enough value into being a part of a good engine. It's like you don't have to be the fuel, you don't have to be the most important piece, but every single piece of the engine is important to make it.
Yeah.
run.
I mean that's why like engines run very smoothly because you need the lubricant.
Yeah, everything.
Yeah, I mean even though even every little piece is designed to specification, but you need an overall governing body to make it work. And then that's just one of the hardest piece of, construction is a lot of managing people, and then that's very hard. And that comes back to automation, is that automation is making each individual pieces very fixed and then very predictable. And then the human will end up being like more of a supporting role in the whole thing.
Do you remember exercises in like high school or even elementary school that were training you to be a good team member?
Yeah, definitely.
Like
definitely.
how would they go about that?
Well, that basically one of the more conventional exercise will be everybody just line up in a big playing field and then do the same gymnastic thing, and then your head of the class and then your teacher will really shout at you, and then in some cities beat you if you don't follow the thing, and then that's a very interesting lesson in life. So that lesson transcribes into later on in life more of everybody but are more familiar to listening to a governing procedure.
What happens to the kid? Because I'm sure in every group there's one kid that says like, "Screw you, it's big trouble."
Well, in the last couple of decades, those people end up being largely successful.
The Alibaba founder.
Well, yeah, he's a very extreme example, but yes. And then, but right after that, like, it's actually never really right or wrong. It really depends on who you are. I mean, like, if you're a person who is really good at studying, really good at following orders, like, you should not do that. Like, it's really up to like who you are and follow your capabilities, but not. I just want to defy something because I want to defy it.
Yeah, there are people like that.
Yeah.
I think I've done that a couple times.
Yeah. Yeah, I mean, but that's how you learn. That's how you learn what type of people you are. Like, it's through experience, it's through just through living it.
So maybe this is dangerous territory, but on the flip side, what things did you learn in America that were kind of novel?
Well, what I learned in America, the value of capitalism.
Sure.
Yeah, it's about creating value, and then it's like the society will reward you when you create real value to society, but also that you have to look out for the people that's pretending to create value. Because that sometimes can really bite you. Because like I live in LA, LA is a city that's
of actors.
Actors, and then you have to really learn how to distinguish who wants to really go with you and then just provide more value to society rather than trying to get value for themselves.
Yeah.
Yeah, and then but it's a two-bladed sword, right? Like from here I learned if you really work hard, and then this is one of the rare countries you can do it. If you really work hard, if you put in your thoughts, you put in your physical, you can actually make a good result for you and for society as well.
Yeah, certainly. If you pick a good thing to work towards and
Exactly.
a little bit smart, maybe helps. Yeah. I think it seems like there's been success stories of entrepreneurship from China too, like the Baba founder, and there's other people who have kind of started from nothing and built businesses there as well.
Well, the thing in China is political matters play a large role as well. You really want to look at what the government wants, and then obviously now the government really wants good living for the people, so you just follow what the government wants.
Yeah, it's interesting to like make that a China thing, especially like you look at Facebook and Facebook's early funding. A lot of that came from the Department of Defense, and so like people criticize China for having government looking at social media, but we're probably not that much different. Like maybe China has better algorithms now. I don't know.
Well, I mean, all governments wants good on their people.
Sure.
It's just the way of implementing that is different at different stages and different times in history.
Yeah, Americans tend to put too much criticism on other countries and maybe not look inwards often, but it's cool to see like more collaboration between countries and like internationally. Historically, maybe that hasn't been as easy for companies to do business.
Well, I mean, I guess at the end of the day, it's people at the end of the day. Like, we as people want to help other people, but we don't also, just want to do it for no reason. You want to do it with a financial, like a financial model that makes sense. So that's why I think technology is very important, because it really increases productivity. And so in this way, like you're just baking the cake bigger. You're not taking away others' cake. You're making the cake bigger, and everyone just end up getting more out of it.
In America, the interest rates are all going up now, so I think that will decrease the risk taking, and maybe we'll see less actors and more doers.
Yeah, definitely.
It's a big problem, like you mentioned, people making crazy claims, or even promising they're going to. So many people tell me they're going to start the next big 3D print construction company. They don't even have a printer yet. They haven't done one print. To actually be doing it in concretes.
Yeah, I mean, this is a concrete business. You have to do every single step very firmly, very steadily. And that's how you can get the best result, or relatively the better result for your efforts. And then every step is important. Like, you cannot miss any step. You cannot jump a hoop or take a shortcut. That would just end up, not making your business work.
So those projects you mentioned in Florida, Arizona, New York, are those for clients or?
Those are all for clients.
Cool.
Yeah, and then all those designs are done, and then we just going through the rigorous process, which we understand the permitting process.
Yeah, it's a pain, but.
I mean, it's understandable. Like, if there wasn't a really rigorous and safe ordering process, everyone can just kind of build a house on their own, and then there will be so much dangerous stories afterwards.
Yeah, the worst thing that could happen is if a house collapses and then they make 3D printed houses illegal or something.
Yeah, exactly.
Stifle innovation.
Yeah, I mean, because 3D printing is not that different from CMU. I mean, it's a giant. If you look at it, it's a giant CMU block, and then the material we use is a lot harder than CMU, and then the hollow part you can always pour inside if the designer and then the engineer choose to do it. Because in theory, it's not that different.
The big challenge is getting vertical and horizontal tied rebar.
Yeah, that's true. Well, but that's also why having a very flexible system helps.
Yeah.
You can really work your way around the design of the engineer. And because you've seen the videos, the robot arm since it's 6-axis, you can print in all different kinds of plane. So you're not restricted. If there's a bar there, you have to go on top. You can go around it, and then still print.
Very cool. So, are you hiring for any positions at the moment?
Yeah, we're always looking for more innovative people in the robotic industry, and then more importantly in the construction industry, because this industry and then this type of business will not work without real life knowledge, real life experience in the space, because it's people who in the construction industry bring to us the real problems.
Yeah, it's true.
That we to solve, not we think there is a problem, then we solve. Like that's the ideology of the last startup bubble, that people we think there is a problem, and then they just do it, and then it turns out not to be a real problem. We want people in this industry to tell us what the real problem is, and so that's why we want to work with people that have the experience, have the knowledge together.
Have you thought about maybe printing your next headquarters?
Obviously, yes. So that's actually the house we're talking about. That piece of land, we're gonna print like a temporary large outside headquarters for us.
Cool.
Yeah, that'll be very interesting to see, because we also have a line of outdoor furnitures, and our current space is not enough to do that in a scale.
Nice. That'll be good to have a product that can go to market now that's cheaper than a printer. And
yeah, because the outdoor furniture, outdoor parts market is very established, and what 3D printing concrete can give to that industry is that you don't have to keep inventory. You can only keep inventory in the computers, and now a lot of it is drop shipping. So whenever an order is filed, the printer just print that file.
Yeah, that's nice.
Yeah, without keeping a huge amount of inventory and molds. But molds are very expensive.
Yeah, molds are that's like the primary benefit. You can make a custom shape one-off without a mold.
Yeah, and then with little cost. I mean, the cost will be to getting the specific dimensions from the customer. That's the only more cost that's come to it.
Ideally, one day you're just sitting in your office and you see the order came in your email. It automatically goes to the printer, and then some kind of autonomous truck picks it up and brings it to the location.
Well, that's up to Tesla to solve that problem.
Yeah, they'll do that. You work on the rest.
Yeah, exactly. And then also from the building industry, I mean, at the end of the day, it will be up to autonomous trucks working with robotic arms. So even though later on there might be even a version where the truck has the robot on itself, has a long-reaching arm that's steady and stable, and the truck will just go there autonomously, and then the concrete and mixer, and then the pump, and the extruding head, and the manufacturers work all simultaneously with the algorithm, and then just producing a building or a structure of some sort, and the human there is just to monitor to keep it safe, and that's the end goal, I guess.
Yeah, it's not going to be easy to get there, but it's a beautiful thing.
Yeah. Well, I mean, if you think about it, it's if you can send people to the moon, if you can send people to space as tourists, I mean, so the technology is there, the stability is there. It's more about getting the cost down to the part that makes sense for us to do. And then that's why our printer is what we consider largely makes sense, is that it really takes the cost down. Because I don't know if you want to talk about cost in 3D printing construction. If you talk about step by step, it's about doing the design in a understandable way. It's about bringing the equipment to the site in a non-expensive way. It's about setting up the machine in a short amount of time in an inexpensive way. And then it's about taking the material, and then the material should be sourced locally. And it should cost, because right now we're actually ordering some material. We were going to order material from like Florida, and then the cost of shipping was more than the material itself, and that just doubles the cost. Of
shipping's crazy these days.
Yeah, and then that shouldn't be that way, because like there's concrete everywhere. Why shouldn't you just source material from locally? And that's why like our mix design works with the most common sand and cement. And then after that, you want to take apart the machine in an inexpensive way, and then you want to like have the finished product overall in an inexpensive way. So that's how we want to do this and how we want to bring to the industry a new thinking of this. So that's why each step of the way, when we design the machine, when we design the procedure, we have cost in mind.
So you're not looking for any kind of investors or anything at the moment, or?
Well, for the investor part, we want to prove to the community and prove to the industry that we already have a capability to produce. Because we don't want
That's smart.
We don't want to we claim that we do this. I'm a concrete person. I want to showcase that we can
Yeah, I
do
like
things
that.
soundly, and we can show a very transparent data sheet of where money is going and where it costs and what can be better, and then from that point on raise money based on that.
I think that's the way to do it, because in construction, like we were talking about, estimates are like so difficult to having an as-built with the real numbers, that would be great.
Yeah, and then that's why currently manufactured homes are great. It's very predictable, but they are also ungraded because you have to fit that in a truck, and then so what we understand is a hybridization between prefab and then on-site robotic construction.
Something you can fit in a truck that builds something bigger than.
Yeah, and then have some of the parts be pre-made, manufactured.
Sure.
Yeah, like the windows, like
even a
wall
bathroom.
system. Yeah, like the bathroom, the wall system, and all of that. So so you get the best of both worlds, and then more ideally, the pre-made parts will be assembled by robots as well. So you really can solve the prefab companies. I have this great design. We can manufacture great stuff, but we can only put it in the truck, and then that's why a lot of the companies. Prefab home looks great, but it's all boxy.
Yeah.
Yeah.
They also have just a negative connotation. People think of them as being cheap.
Well, yeah, I mean, like, because bear in mind, that's a house that you have to transport. So being transported, you have to make the house so much rigider, and then that's a lot more cost than building on site. So, and then you're obviously transporting a space rather than a solid piece. So all of that is cost, and then you want to keep that at a level of the current construction rate on site. That sometimes means cutting some of the more luxurious or like better features of the building.
Yeah. Is there anything left unsaid that?
I think we will talk more when we started the print, and then walk through some of the projects we have done.
Cool. Thanks for sitting with me. It's been great learning more about AI,
Yeah, it's
RIC.
great to see you.